Alright, class number 1 is actually a review from yesterday. Synthetic division, again, shortcut to doing long division when you are dividing by a binomial. It only works with a binomial. So remember, if your factor on the bottom is x plus 5, we're going to be dividing by negative 5, because that is what the factor would be there. Then you have to fill in the coefficients. X cubed has a 1, x squared has a 7, x has no number. Make sure you remember that placeholder. And then the number itself is 49. To synthetically divide, remember to bring down the first number, multiply it by the negative 5, and then add down. 7 plus a negative 5 is 2. 2 times negative 5 is negative 10. When you combine those, you still have negative 10, and you have 50. So that means you have a remainder of 1. So x plus 5 is actually not a 0 of the function, because you can't evenly divide it out. But, so for this problem, the answer is x squared plus 2x minus 10 plus a remainder of 1 over x plus 5. Again, just a little review from yesterday. So, let's go on. We also talked about factor theorem again yesterday. It's a factor if you plug in the number, you get 0. Okay? Now, to factor polynomials that you can't do grouping on, this is the whole purpose. We've been able to factor everything without using our calculator, without doing anything else. Now we're looking at something and we can't do grouping. So, because if you tried grouping here, you pull an x squared out and you pull a negative 1 out, they won't match. You'll get 2x plus 1 and an x plus 3. Those won't match. So, you have to try synthetic division, but we don't know where to start with synthetic division. Well, back in the day, this is how they figured out where to start. The Rational Root Theorem states that any of the possible zeros are the factors of the constant p, that would be this one up here, so negative 3, or 3. This would be p, over the factors of the lead coefficient. This would be q. So for the problem above, my possible zeros, well, what are factors of 3? We have plus or minus 1 and plus or minus 3 are factors of 3. Factors of 2 are plus or minus 1, plus or minus 2. So, possible zeros for this problem would be 1 over 1 and 1 over 2, so plus or minus 1, plus or minus 1/2, plus or minus 3 over 1 is 3, and plus or minus 3 over 2, which is 3/2. So, what this is telling me is one of those numbers is a potential 0 for the problem. So back in the day when they didn't have graphing calculators, they would have to do this theorem and then plug in each number into x to see which one gave you 0. And then that's how you knew which one to use to synthetic divide, so you can factor it. So organize the terms, list the possible factors, use synthetic division. We're going to do that next. Try to factor the new depressed polynomial, and then list the factors. So, here we go. Let's go on and do that. So, for this next one, it's the same problem. Use the rational root theorem to list all the possible rational roots. I just did that up there. It's plus or minus 1, plus or minus 3 over plus or minus 1, plus or minus 2, because it's the same polynomial. So you get so one of these is a root for this problem. How do we find out which one it is? Well, luckily you guys have technology. So, when you get to this point, because this is not factorable by any means that we have been doing before, you look at your graph. So here's the graph of that function, 2x cubed minus x squared minus x minus 3. Okay, when you type that in your calculator, you get a graph that looks like this. Now, right away, there is only one 0 here. Even though there are 3 answers to this problem, that means that there's only one real solution and 2 imaginary, which means that this solution here has to be the 0 that we divide by. So let's find out what that is, although you guys can probably guess based on where that is. That looks like about 1.5 or 3/2. 3/2 was one of our solutions on our possible options for that number, but let's figure it out for sure. Let's do second calc or second trace 5 and go over there and make sure it is 1.5. And sure enough, one of our zeros is 1.5. Okay, so let's go back to the problem. That means that I know x is equal to 3/2, or my factor is x minus 3/2 is equal to 0. That's one of my factors for this problem, because 3/2 was my 0. Now I use that to factor the rest. I synthetically divide by 3/2 to see what comes out of that. So 2 times 3/2 is 3, because the 2's cancel. Bring down the 2. 2 times 3/2 is 3. Again, bring down a 2. 2 times 3/2 is 3. And these become 0. We know we did it correctly if you get a remainder of 0. It should be 0 because that was a 0 of our graph. Now, so this is part B. I'm factoring it completely. Next, I'm going to rewrite it out. So this is my remaining factor. So I have my function is x minus 3/2 and 2x squared plus 2x plus 2. We're not done yet though, because first of all, we do not like factors with fractions, and this can be factored out. So here's what you do. Take the 2 out of this. So we have 2 times the quantity x minus 3/2 times the quantity x squared plus x plus 1. And then again, we don't like this fraction in here. So instead of using the 2 in this trinomial, we're going to multiply the 2 into here, which is what you're used to seeing. So my final factored form of this is 2x minus 3 x squared plus x plus 1. So this is part B. The answer to part B. That is the completely factored version of this polynomial, and again, we got that from using synthetic division, using that 0 we found on our calculator, and then manipulating it so it looks clean. C, find all the zeros. Well, we found one of the zeros. C, one of the zeros is x equals 3/2. We found that right off the graph. You can find all the zeros off the graph if they're all nice. However, this one we know we're not, because there was an imaginary, they didn't cross the graph ever again. So the other 2 are imaginary. Now we're just going to be doing what we did before. We're going to solve this for the other 2 zeros. We want to set this equal to 0. So I have x squared plus x plus 1 equal to 0. That's the other option here, and this means I have to use quadratic formula. So x equals opposite b, so minus 1 plus or minus the square root of b squared, which is 1, minus 4 times 1 times 1, so that's it, all over 2 times 1. We get negative 3, which makes sense because I said we get imaginary solutions. And so my last solution is, my last 2 solutions are x equals negative 1 plus or minus I root 3 over 2. And that is the answer to C. C is the 3/2 and the negative 1 plus or minus I root 3 over 2. Those are my 3 zeros for the problem. This is it completely factored using synthetic division. And that is all we have to do. So let's do it again. I want you guys to stop after this next one. I'm going to do both of them for the video, so you could go back and check, but we're going to do number 4 in class. So we're going to just look at number 3 right now. First thing you should do, possible roots. Again, possible roots are the coefficients of this over the coefficients of this. So it's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8 over plus or minus 1, plus or minus 2. So the first thing I do is I just do all the 1s over 1, which is plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. All these could be zeros, and then I could have 1/2. I could have 2/2, which is 1. We already have that one there. I could have 4/2, which is 2. I already have that one there. And I could have 8/2, which is 4. So actually, that's the only extra one I could possibly have, is the plus or minus 1/2. So these are all possible zeros of this function. Next step, we have to find out which ones they actually are. Again, find all the ones that are possible from the calculator. So let's go to our calculators now again. When you graph this polynomial, you should get a graph that looks like this. Okay? Notice how you have 3 real solutions. That does not mean that they're going to be nice rational solutions. Some of them could be real but irrational, but at least we know they are real. So we can check each one to see if we get a nice 0 or not. So let's do that. Second trace 5. Hit up so you're on the y equal line, and then move left or right. I'm going to hit enter there. Enter, enter. I got -2, 0. So we have one of the zeros that is really nice. Let's put that one down. So I'm going to just list that over here. X equals -2. Okay. Let's go back to the calculator. And now I'm going to do second trace 5 again. And I'm going to hit down just to get onto the y equal line and go over to the other point. You get -1/2, 0. So that's a nice one too. I'm going to get the third one before I write that down just because I want to have all 3. Now that I got 2 of them that are nice, you know the third one will be nice, because usually the rational solutions come in pairs. You get usually a plus or minus value. So -1/2, and what's the third one? And 4. Remember, 7e -12 is the same thing as 0. So I have 4, -1/2, and -2. So x equals -2, x equals -1/2, and x equals 4. Alright, so these are my solutions. So this is actually part C already. We kind of skipped B because we didn't need to do B to do C. However, I do need to write this in factored form. And here's where you have to be careful. When you have all the factors, a lot of you guys will tend to do this. And this, I've been guilty of this myself. If x equals 4, that means one of my factors is x minus 4. If x equals -2, if I move it over and set it equal to 0, I get x plus 2. And then this one here, you would say x plus 1/2. Now the problem is, within the factoring, there should be a number 2, right? Because this is 2x cubed. Well, if I multiply x times x times x, I only get x cubed. This factor here is missing its 2, because we just went right to the graph to get our answers. So you have to remember that if you do all the answers by graphing, that if there is a factor with a fraction in it, you have to multiply by the number that is in front. So, because otherwise we don't have it and it's not actually factored the right way. There should be a 2 out in front. So I'm going to multiply the 2 into this one because that's the one with the fraction. So my actual factored form for this polynomial is x minus 4, x plus 2, and 2x plus 1. And that is it. And you can always double check by typing in your y2 or y3, whatever you want to do, this function, and see if it overlaps the first curve. It has to look just like this one. Okay? So, that one we didn't have to do any synthetic division because all the zeros were nice. So we are going to, on the next one I'm going to do in class, like I said, I'm going to do the next one in class, so you can stop your video now. I'm just doing it so that in future you can go back and look at it. Alright, so possible zeros for this one. Plus or minus 1, plus or minus 2, over plus or minus 1, plus or minus 3, which means that I could have plus or minus 1, plus or minus 2, plus or minus 1/3, and plus or minus 2/3. Okay? Now I'm going to look at my calculator to see which one my zeros are. Now notice that this is to the 4th power now. 4th power means that there's going to be 4 answers, so we might get 2 zeros that we want to use. So let's do that. Alright, this is the graph of the 4th power function. You have a 0 here, a 0 here, a 0 here, and a 0 here. So all 4 are real, but they might not all be nice. So let's find out. I'm going to just quickly go through each one and find the nice ones, because that's what you're supposed to do. I would check all of them real quick, just to double check. So this one over here, -2. Okay, that's a nice one. Keep that in your mind, or write it down. I'm going to keep going. -2. that is not anything. That is not a fraction that's nice. So that is not one of the ones we want to use. So negative 2 is still one of the nice rational roots. Hopefully you guys recognize this decimal as 1/3. 1/3 is the other one. Now, I know I can stop now because the irrational ones come in pairs. So this one was irrational, which means this one probably will be irrational also. You never just get one irrational solution. So my two zeros that I can use are negative 2 and 1/3. So let's go back to the thing. All right, so I have x equals negative 2 and x equals 1/3. Now, that only gives me 2 of the 4, which means I have to synthetically divide twice. So here's what I do. I will divide by the negative 2 first, just because it's easier to do non-fractions when you have more numbers. I bring the 3 down. I get negative 6, negative 7. You get a 14. You get a 1. Actually, that's a negative 1. That's positive 2, which is a positive 1. 1 times negative 2 is negative 2, which is 0. All right. That means that we factored out the negative 2. Now, guess what? We know we have to factor one more time because we are not down to a quadratic yet. So I'm going to just right away take my new answer. Remember, this is 3x cubed minus 7x squared minus x minus plus 1, and factor it into the 1/3. I wrote 1/2, but it's 1/3 is my other 0. So I bring the 3 down. 3 times 1/3 is 1. Negative 6 times 1/3 is negative 2. Negative 3 times 1/3 is negative 1. And we get a 0. So again, that also divided into it. So here's what happened. We have my final function has the factors of x plus 2, x minus 1/3, and 3x squared minus 6x minus 3. Again, we don't like it in this form because we have a 3 in here but nothing in there. We want to take this 3 out. And when you do that, you're left with this. And then multiply it into the one with the fraction because we don't like to see the fraction. So we have f of x is equal to, and this is my final factored form, x plus 2, 3x minus 1, and x squared minus 2x minus 1. There's my function. Now, we have, so this is part B. Part C, I want all the zeros. Well, we already know x equals negative 2. That's one of them. And x equals 1/3. That's the second one. We also know that this piece in here we haven't solved yet. Again, we can use completing the square or quadratic formula. I'm going to do completing the square for that one, just because it has a 2 in the middle that you can divide out. So I'm going to say I have x squared minus 2x minus 1 is equal to 0. Half of negative 2 is negative 1. Squared is a positive 1. So there's a negative 1 here. Okay, so I'm going to rewrite this in factored form. I'm going to move over the 2. I'm going to take the square root. Plus or minus, do not forget that. And finally, my last two answers are positive 1 plus or minus root 2. You could have also used quadratic formula to solve that and get those final two answers. But again, I have my 4 zeros now. 2 of them I got from the graph. You always can get enough to synthetically divide down to a quadratic, and then you can use the quadratic formula to solve for those last two. Okay, so like I said, this last one, hopefully you guys just are looking at it to study. I told you guys I'm doing number 4 in class, so if you did it already, you could work on something else, but we're going to talk about it in class. All right.